All right, I'm going to continue the videos on section 5.1. So we're getting started with trig, and there's a whole lot of vocabulary that we use that kind of goes back to our geometry days. And so in 5.1, they go through a lot of that vocabulary. So I'm not going to try to write out word definitions of these. Just want to try to illustrate what we mean by each of these things. Okay, and so with these first four, I want to just draw an angle. So an angle is composed of two rays, they're called, that meet at a point. That point where they meet is the vertex. And then you can designate one side as the initial side and one side as the terminal side. Okay, so let's say this one's the initial side and this one is the terminal side. Because the way you think about an angle is that maybe it started as two rays kind of right here, sort of on top of one another, and then you pulled one of them away, okay, to create some separation, and it's that makes your initial and your terminal side, okay? And so the angle is the whole entire thing. This whole thing is called your angle, okay? And so it has an initial side, a terminal side, it has the vertex. And then what you think of as the angle is later is kind of this, the amount of rotation that you have there, okay? All right, let's go on and look at the next three go together. All right, so when you have an angle that's in standard position, what that means is it's like we're thinking about the coordinate plane that we've been using throughout our algebra classes. And then if we position the initial side right at the origin and running along the positive x-axis, okay, and then your terminal side could be anywhere, okay, so maybe we've rotated the terminal side and maybe it's over here, okay. So if the initial side is on the positive x-axis, that's going to be in standard position. So the initial side is on the positive x-axis. Okay. All right, and then let's talk about positive angle versus negative angle. See, with the angle I just drew, see how I rotated the terminal side counterclockwise? All right, that's actually a positive angle. Kind of works like the quadrants work. We'll see that in a minute. You know, when you label quadrants, it's 1, 2, 3, 4. Angles are positive if you're moving counterclockwise. So I'm going to write that over here. So positive angle if it's counterclockwise. And a negative angle if your rotation is clockwise, like a clock face, okay? So here's a negative angle. If we have the initial side on the positive x-axis, it's in standard position, and then it can rotate clockwise. That would be a negative angle. Okay, so for standard position, the key is initial side is on the positive x-axis, like it was on both of these, okay? All right, quadrants, you might be somewhat familiar with that if you've done some graphing recently. Quadrants are a lot of times referred to using Roman numerals, and then you go and you label them counterclockwise. Quadrants 1, 2, 3, and 4, okay? All right, so those are your quadrants. And then the quadrantal angles, okay, those are the angles that have the terminal side on one of the axes. So I'll write that here. So the terminal side winds up on an axis, okay? So say we have our initial side here. This would be a quadrantal angle right here because we wound up with the terminal side on the negative y-axis, okay? Let me do another one. All right, this would be a quadrantal angle if I wind up rotating to here. Okay, that would be a quadrantal angle because it wound up on the positive x-axis. So when you think about it, your quadrantal angles, you know, you're familiar enough with degrees for me to go ahead and mention that, would be like 90 degrees, 180 degrees, so like 90 degrees, 180 degrees, 270 degrees. And then when you come back around, started at 0, came back around, it's at 360. And you can wrap around multiple times on some of these problems, but I'm going to just stop there. All right, we're going to talk now about the measure of an angle. And we're going to start by talking about the measure of an angle in degrees, but then we're also going to learn about how angles can be measured in radians. Okay, but let's think about the measure of an angle. Okay, so first off, when you're measuring an angle, like so say you have an angle like that, what you're really trying to measure is this. It's like one way to think about it is think about it as the amount of rotation. Okay. You're trying to describe that to somebody so they understand how much you've rotated the terminal side away from the initial side, okay? And so when you think about that, okay, like let's say we had a situation where we rotated all the way around, okay? That would be one whole revolution. That would equal 360 degrees. And you're familiar enough with degrees, I think that would make sense. Okay. All right, now let's talk about acute angles, right angles, obtuse angles. These are a lot of times referring to angles in a triangle and whether those are acute, right, or obtuse. So like an acute angle, the measure of an acute angle would be let me label an angle. A lot of times we'll label it using Greek letters, and this one is theta. It looks like an O with an extra little piece to it. So, you know, if theta is less than 90 degrees and greater than 0, it's acute, okay? And then for a right angle, it has to equal 90 degrees, okay? If theta is a right angle, it would have to equal 90 degrees, right? An obtuse angle has to be bigger than 90. And so an obtuse angle would be one that's bigger than 90, but less than 180. So between 90 and 180. All right, and then a straight angle is when you start out, okay? And then your angle winds up at the end just looking like a straight line. And it doesn't have to be on a coordinate plane. So, you know, you could have your one side here, you rotate, as long as it winds up being a straight line. So for that to happen, you can kind of see that your theta would have to be 180 degrees. And by the way, in geometry, we make a big deal about notation, and like we would put measure of angle A and that sort of thing. A lot of times here, when we say theta equals 90, sometimes theta is referring to the angle itself. Sometimes it's referring to the measure of the angle. But it's easiest just not to bog down with notation. And so the Blitzer book just says theta equals so many degrees. Okay. All right, now let's go ahead and do just a little bit more, and then I'll stop the video and we'll start up again later. Okay. All right, so the next chunk of vocabulary words deals with circles. So let me get a circle drawn. Okay. And the circle is actually that set of points right there on that boundary. All right. And then it's formally defined as the set of all points that are equidistant from a given point. The center of the circle is that. Okay, right there. The circle is all the points that are the equidistance around it. All right. Now the radius would be the distance from the center to a point on the circle. And it doesn't have to be in that orientation. It could be anywhere on any point on the circle. That would be the radius. Okay. So this is the radius. All right. And then let's imagine that we create an angle here. So let's suppose, let me erase this little line right here. And let me label that this way. That's the center. All right, so let's suppose that we're putting an angle, superimposing an angle on here. And so the initial side is there, and let's say we rotate it to right here. So we're imagining this angle. All right, and I'll go ahead and get you to note that, see, this is equal to the radius, and so is this piece right here, from here to here. Same, it's also equal to the radius. All right, so want to get you to think about what this is called. See how this is the piece of the circle that was cut off by that angle? That is what we call the intercepted arc. Okay, that's the intercepted arc. All right, and then one other thing I want you to notice is that the particular angle that I drew, the vertex of the angle was the center of the circle. When that's the case, you've got a central angle. The vertex of the angle is the center of the circle. Okay, when that happens, you have a central angle. You know, there can be angles that go from a point on the vertex is on the circle. So like something like that. Okay, that is not a central angle. Okay, so the central angle would be the red one. So theta right here. Theta is a central angle, but the green one is not, okay? All right, so I just wanted to get a lot of the vocabulary out of the way. So I'm going to stop the video here, then I'll do another video getting at a little more about what a radian is. Actually, let me try to squeeze that in if I can, because you're going to watch the video demo on a radian, so I won't go overboard on this. So I really want you to watch the video on the like physical demo of this. Radian is just another measure, another way to measure an angle, to think about the measure of the angle. Okay, and so let me draw an angle again. So let's say we have one in standard position that looks like this. Okay. All right, when you're looking at that, we see that that angle has cut off that amount of an arc, okay? So like before, that one has cut off that amount of an arc. All right, the way to think about a radian versus a degree, excuse me, is that radians is kind of having you look at how long the arc was relative to the radius of the circle, where the degree is looking at what this rotation was, how many degrees you rotated the terminal side through. But they're both ways to indicate the size of an angle, okay? And so if I was trying to talk about what this angle would be in radians, let me call this one theta, then I could talk about theta as being equal to whatever this length is. I'm going to label it S. They're going to do that later. So it's like the length of the intercepted arc, okay, divided by, you would compare that to the length of the radius right here, okay, length of the radius. That would be theta in radians. So in this case, it would be whatever the length of the intercepted arc is divided by r. And that would be theta in radians, okay? Let me write that here. Okay, so it would be the length of the intercepted arc divided by r. So the way to really think about it is theta in radians is the number of radiuses in the intercepted arc. It's like you're looking at how long the intercepted arc is relative to the radius. How many radiuses is it? Is it one radius, two radiuses? Is it 2.35 radiuses? And the way you determine that is you take the length of the arc divided by r, and that tells you how many radiuses there are in this piece of the circle. Okay, so one more comment I want to make on this, and then I'll stop the video, is that if we take, let me see if I can, I'll just do it right there. If we take the initial side and we take this radius and we bend that radius, we take the pipe cleaner like you saw in the video, and we go to the point, make the intercepted arc the same length as the radius. So this right here, okay, is my new angle. Okay, this was the old one here. Let me just put it back. Okay. All right, so I'm doing my new angle, and I'm making it where the radius is the length of this intercepted arc. So this is R right here. Okay. And let me call that angle, this angle right here, I'll call angle beta. Then beta would have the measure of the intercepted arc being 1 radius. And when you divide by the radius of the circle, see how you get 1? And it would be 1 radian. Okay, so when you take the length of the intercepted arc and you divide by the radius, that is determining the measure of the angle in radians. So we would say that would be 1 radian, okay, where the radius equaled the length of the intercepted arc. Okay. All right, so in this case, beta was 1 radian. All right, so please do watch the video and really think about how a radian is kind of having you look at the length of the intercepted arc as compared to the radius, where a degree is having you look at the amount of the rotation from the initial to the terminal side. But they're just two different ways of talking about the measure of an angle. Okay.